let's do some more. So in the homework, question 22, perfect cubes. So let's do 22a is 27 q cubed minus 125. So is this a cubed plus b cubed or a cubed minus b cubed?
Minus.
Okay, a cubed minus b cubed. So that's the formula I want to use. So let's identify a. Take the cubic root, 27.
3.
And the cubic root of q cubed.
Q.
Q. So my a value equals 3q. And the b value, cubic root of 125.
Equals -5.
Okay, so I just want to ignore negatives pretty much, because this has to do with which formula I use. It doesn't necessarily affect the answer. Okay, so a cubed minus b cubed, what does it equal? A plus b or minus b?
Minus.
A minus b, and then what's in the second set of brackets? A squared
Plus AB plus B.
plus ab plus b squared. So then redo this using this setup. So a minus b, what's my a value?
3Q.
3q, and my b value?
5.
Minus 5. Okay, and then a squared.
3.
So 3 squared, 9, q squared. So a squared plus a times b. So a times b,
15Q.
15q plus b squared,
25.
25. 25. (22b) is n cubed plus 8 over 27. Okay, it's a fraction, but we can still cube it. So does this look like a minus b cubed or a cubed plus b cubed?
A plus.
Okay, so we want to use the plus formula. So let's identify what a is. So take the cubic root of n cubed. N. Then let's identify b. Take the cubic root of 8.
2 over 3.
2, and then the cubic root of 27 is 3. Okay, so there's my a and my b. And I have a cubed plus b cubed, so I want to use a plus b times a squared minus ab plus b squared. And I usually write that out in each problem to make sure I copy everything right. So then rewrite it. A is n. I have n plus 2/3. And then n squared minus 2/3 n plus my b squared value. So 2 squared is
It's 4 nines.
4, and 3 squared is 9. (22c). So same, this one's now a decimal. B cubed minus 0.125. So this one looks very similar to this one, only it's in a decimal version. Okay? The same thing, just identify a and b. Okay, so the cubic root of b cubed is b, so there's my a value. And then the cubic root of 0.125 is 0.5. Okay. So I want to use the a minus b format. So a minus b times a squared plus ab plus b squared. Okay, just rewrite it. So my a value is a b and my b value is a 0.5. And then a squared is going to be a b squared plus 0.5b plus 0.25. The tricky part on these comes in is when we're trying to remember negatives and positives. So if you always copy this formula down ahead of time and then just plug in your numbers, it will help you keep the positives and the negatives straight. $22D is 3r to the fourth minus 24r. Okay, right away I know that's not a perfect cube.
You can take out the r.
Okay, I can take out one of the r's. How about our numbers?
Either one of those are perfect cubes.
Neither one of those are perfect cubes. So if I pull out the 3, then I'll end up with r cubed. And what's 3 into 24? R cubed minus 8. Now those are both cubes. So let's identify our a and our b. So the cubic root of r cubed, so a equals r, and then the cubic root of 8, 2. So then I have r cubed minus 8, so I know I'm using the a cubed minus b cubed format. So my answer needs to be a minus b times a squared plus ab plus b squared.
So it's 3r. The final answer would be 3r, parentheses, r minus 2, parentheses again, r squared plus 2r plus 4.
R, 2r plus 4.
Is that correct?
That is correct. Okay, let's do another one of those. What if I have 8x cubed plus 64?
I'm going to take the 8 out of the scenario.
If I take the 8 out, what's going to happen?
It's going to change it to x cubed plus 8.
Okay, take the 8 out. X cubed plus 8.
Which is a perfect cube.
This is actually a perfect cube too.
Oh.
Can you figure out how?
Well, I guess the 8 is a 2.
Okay, the cubic root of 8 is 2.
So it'd be 2x.
So 2x would be my a value. And then how about 64?
4.
4. Okay. So my b value would be a 4. So I can do it either way. Okay. So this is an a cubed plus a b cubed, so I want to use the a plus b format. So a squared minus ab plus b squared. Okay. So let's plug in our values. So a plus b, 2x plus 4.
And then you have 2x squared.
So 2x squared is
2x squared. Oh, 4x.
4x squared. Okay? Minus AB. So A times B,
8x.
8x, plus B squared, 16. So in 24, it says to use the U substitution, which we're not going to do. So I've got x to the 6th minus 26x cubed minus 27. So it's a trinomial. So I should be able to factor it using two sets of brackets. X to the 6th. X cubed times x cubed will give me x to the 6th. Factors of 27?
3 and 9.
3 and 9?
1 and 27.
1 and 27. Which one's going to get me to 26?
1 and 27.
1 and 27. So 1, 27. Positives, negatives?
Positive on the 1 and negative on the 27.
Positive on the 1, negative on the 27. Very good. 24b is 3 times n plus 5 squared plus 2n plus 10 minus 21. That's pretty ugly looking. I think we can do some grouping here. N plus 5 looks like it's going to be my base. So if I have 3 times n plus 5 squared, how can I turn this term into an n plus 5?
Squared.
I want to end up with n plus 5. What can I do?
And we'll by 2.
Okay, if I pull the 2 out, it'll be 2n plus 10. Here we go. And then that's in brackets minus 21. What's my similar term here?
N plus 5.
N plus 5. That is ugly. That is really ugly.
So what, n plus 5, and then in brackets you got 3 times. Actually, I don't know, so that's cool.
N plus 5 is our similar term here. And then what have I got left over?
3, 2, and minus 21.
Okay, I've got a 3 plus a 2. And then a minus a 21. And one of these is squared.
Wouldn't it be the n plus 5?
Yes, but that changes how we need to do this one. Let's try. Well, that's not helpful at all. What is wrong with this eraser, I swear? It doesn't work. I don't know why it doesn't. Okay. We're just going to give up on that one. Let's skip ahead and do 26. That looks like it's going to be yuck. So 26a, this should give us some good factoring practice though. X squared minus x plus 6. So what times what is going to get me to x squared?
X.
X times x. And then factors of 6, 1 and 6, 2 and 3. I need a 1, so let's use the 2 and the 3. Positive and a negative, one of each.
Positive 2, negative 3.
Positive 2, negative 3. That will leave me with negative 1x. So then our b is very similar. X squared plus an x minus 6. So x and x will take me back to x squared. Same factors of 6, and I want to end up with a positive 1 this time. So which is the positive, which is the negative?
Negative 2.
Negative 2, positive 3, leaves me with 1x and a negative 6. C, x squared plus x plus 6. X, I have a plus a 1x and a positive 6. Is there any way I can make that happen?
With the 1 and the 6.
If I have a 1 and a 6, that will get me to 6, but then how do I get a positive 1 out of that?
Make them both negative?
So if they're both negative,
No, I'd make it negative 2x.
I'd have a negative 3 and a negative 2. That will give me my positive 6, but how many x's would it give me in the middle? Negative 5x. And then if they're both positive, I still get my positive 6, and then I end up with a positive 5x. So C is an example of
Prime.
a prime version. D, x squared minus x minus 6. So again, x and x, then factors of 6 that are going to get me a negative 1.
Positive 2, negative 3.
Positive 2, and negative 3. So that'll give me a negative 6x and a negative 1x in the middle. E, x squared minus 5x plus 6. So we have that one a little bit down on example C. Which combination would get us to the negative 5x? I have x and x, 2
Put 'em
and
both
3.
negative.
Both negatives. There's my negative 5x, and then they'll give me a positive 6 on the end. And then F is x squared plus the 5x minus the 6. Okay, so x and x, 2 and 3. Is there any way to make it work? No?
No, the only way to get a positive 5 would be to do them both positive, which ends up with a positive 6.
Okay, so if those are both positive, I get my positive 5x, but I also end up with a positive 6. So let's try our other set of factors and see if those work. 6 and a 1. Can I get a positive 5x and a negative 6?
Yeah, positive 1, negative 6.
Positive 6x minus a 1x give us our positive 5x and then a negative 6. Okay. So basically the same equation, 6 different ways, 6 different sets of factors, one is prime. B squared plus 9b plus 20. Okay, Bart. Factors that are going to give me a b squared. What times what? It's b squared.
B.
So b times b. Okay, factors of 20. 1 and 20.
5.
2 and 10, 4 and 5. Which one's going to get me to 9?
4 and 5.
4 and 5. Then I'll have a b squared, a 5b, a 4b, and a 20. So our numbers all work out. So 5 plus 4 is 9. So these both need to be positive. There's our answer. $30, 10z squared minus 140z plus 450. There's some great factors in that one. One thing you can do right offhand to try and make it easier is divide by 10. Right, those are all divisible. So that would be 1z squared minus 14z plus 45. And if you can solve that, then try and apply it to that one. So, what times what is z squared? Z. Factors of 45?
Yeah. 9 and 5.
9 and 5. That will get me to 14. Okay. 9 and 5.
Both negative.
Both negatives. There's my negative 14z and my positive 45. So z squared minus 14z plus 45. Okay, so then if I times it all by 10, will it still work? Yeah?
Yes.
$32 is 25 minus 16n. Okay, what's the first thing I need to do?
That's pretty much a perfect square on that.
Let's put them in the right order. Negative 16n plus 25. They're perfect squares, right? Each of those factors is a square.
Yeah, but you can't get a negative 16 off of those.
What should I do? Remember?
Yeah.
Pull out a negative. Okay. Now I can do
Now
perfect
it's
squares.
Perfect square.
Okay. Square root of 16
4 and
and square root of 25? 5. So then remember I used the binomial conjugate so that my middle terms all cancel and I end up with 16n squared minus 25, and make sure you carry down your negative 1. $34 is 28 plus s squared minus 11s. Are they in the right order?
Nope.
Nope. So let's start there. S squared minus 11s plus 28. Okay, so there's a trinomial. So what times what is s squared?
Yes.
S. And then factors of 28.
7 and 4.
Let's use the 7 and the 4.
Both negative.
Both negative. So I'll get s squared minus 4s minus 7s. There's my minus 11s. And then a positive 28. Okay, number 36. Factors of 3 are 1 and 3. We're going to have a 3k and a k. Factors of 8, 1 and 8, 2 and 4. Bart, where are you? Down there. Which factors do you want to use, Eddie? 2 and the 4. Which one should go where?
The 4 on the inside and the 2 on the outside.
Positives or negatives?
Positives.
Both positives. So that will give us 3k squared plus 6k plus 4k. There's our 10k plus 8. Okay. 38. 4p squared minus 20p plus 25. Nothing I can pull out of all three, so we'll try and factor like this. So factors of 4.
2.
1 and 4 or 2 and 2.
1 and 4.
So let's try the 1 and 4. So I'll do a 4p and a 1p. Factors of 25. 1 and 25. 5 and 5. I need to get to 20 in the middle.
Then use the 5 and 5.
If I use the 5 and the 5, positives or negatives?
Negatives.
If I do 2 negatives, so I'll end up with 4p squared minus 20p minus 5p. So I ended up with negative 25p. So that combination didn't work. Let's try a different one. Let's try 2p and 2p. You want to use 125 or 5 and 5?
5 and 5.
5 and 5. Positives or negatives?
Negatives.
Negatives. So I'll end up with 4p squared minus 10p minus 10p. There's my negative 20p plus 25. Okay. So that's the correct combination. 2p minus 5 times 2p minus 5. $40 negative 28 z cubed plus 16 z squared plus 80 z. It looks like there's some terms I can pull out of all three. I can pull out a z for sure. A number. Are there any numbers I can pull out of there?
4.
4?
Makes it 7z squared.
Okay, let's make that a negative 4. If I pull out a negative 4, what do I multiply a negative 4z by to go back to 28z cubed?
7z squared.
7z squared
Plus 4.
minus 4z
Plus 20.
plus 20. That hopefully is a little more factorable. The factors of 7 are 1 and 7. So 7z and a 1z. Factors of 20, 1 and 20, 2 and 10, 5 and 4. I need to get to 4, and I've got this 7 to worry about. So is there a combination up there that's going to get me to 4, working with a 7?
No.
Start trying them. How about the 2 and the 10? Is there a way to make 4?
Not that I see it. Oh, I was looking the other direction. I hate that part.
7z squared, 14z, and a 10z. Okay, I should be able to make a 4. Which one needs to be positive?
Positive
Okay.
2.
A negative 14 and a positive 10. So a positive 10, negative 14, and that will give me my negative 20 at the end. (42) negative 30n minus 4n squared plus 2n cubed. So what do I need to do first thing?
Put them in the right order.
Put them in the right order, okay? 2n cubed minus 4n squared minus 30n. Is there anything I can pull out of all of the terms?
The n.
An n? How about a number?
The 2.
And a 2. Okay. So what do I multiply 2n by to go back to 2n cubed?
2n.
N squared. Then how about to get back to negative 4n squared?
Negative 2.
Negative 2n. And then to get back to negative 30n. Negative 15. Okay, so let's try to factor that one. N squared minus 2n minus 15. So what times what will give me an n squared? N.
We need to use a 3 and a 5 factor.
Okay, 3 and a 5. Which positive, which negative?
Need a negative 5 and a positive 3.
Okay, I want to end up with a negative 2n, so I have negative 5n plus 3n will give me my negative 2n and a negative 15. And then I need to remember I have this term right here. So my final answer would be 2n times n minus 5 n plus 3. (44) b squared minus 9b minus 36. Is there anything I can pull out? Nope. Okay. What times what is b squared? B. And then factors of 36. 1 and 36. 2 and 18. 3 and 12. 4 and 9.
I mean, 12 would probably be the best option.
6 and 6. So 3 and 12, I want to get to 9.
Positive 12, negative 3.
Positive 12 and negative 3. So that will give me my b squared, positive 12b, negative 3b, and a negative 36. So did that give me a negative 9b? Gave me a positive 9b.
Oh, that's right. We need negative 12, positive 3.
Okay, so if I make that a positive, I make that a negative, then I would end up with b squared minus 12b plus 3b minus 36. Okay, so that's the one we want. So watch your signs. 46, 27r cubed plus 64. So I know right offhand that's a perfect cube. That's an a cubed plus a b cubed right there. So let's identify our a and our b. So the cubic root of 27 3, and the cubic root of r cubed.
R.
So there's my a value, 3r. And then the cubic root of 64. 4. So there's my b value. Okay. Then it's a cubed plus b cubed, so I want to use this formula. A plus b times a squared minus ab plus b squared. And just substitute in. So a plus b.
3r plus 4.
3r plus 4. And then a squared. 9r squared. Don't forget to square both parts. Minus ab minus 12r
16.
plus 16. Two more. 48 is n squared minus 14n minus 36. Okay. So what times what is n squared? Factors of 36. 1 and 36, 2 and 18, 3, 12, 4 and 9, 6 and 6. And I want to get to 14.
I don't think there is a combination of those. It's going to get to 14. That's prime.
There is not a combination. All right, 18 and 2 will either give us 16 or 20. 3 and 12 will give us 9 or 15. 9 and 4 will give us 5 or 13. And 6 and 6 will give us 0 or 12. So there's no, we'll say that's prime. 50 x cubed plus 3x squared minus 4x minus 12. Since there's 4 terms in this equation, I'm going to try to separate it in group. So I can pull an x squared out of both of those. That will leave me with x plus 3 over here on this side. And then I want to try and get an x plus 3 on this side. So x plus 3 will be inside my brackets. So I have a negative 4 outside. Then I want to group my terms that are the same together. X plus 3, and then whatever's left over, x squared minus 4.